Hello again. This is Jennifer Martinez, and in this video we're going to talk about right triangle base definition of trig functions. In the last chapter, the trig functions were based on x, y, and r. So for instance, if we come down here, it says let A, this is angle A instead of theta now, represents any acute angle in standard position. We know from the last chapter that sine of A was y over r. So instead of y and r, I'm going to think of this as how they are placed with respect to A. So if I come over here, let me do this in yellow, I realize that y is literally the opposite of A. So y is going to be the side opposite to A. I'm just going to call it opposite. It's going to be the opposite over the r. The r is across from the 90 degrees, so I'm going to call that the hypotenuse. Cosine, let's do that in a different color, green. Cosine is literally touching A, it's adjacent. I realize r is touching A as well, but r is across from 90 degrees. He's going to stick being the hypotenuse. It's just between x and y, and x is the one that's touching the A between the x and the y is the opposite. So I'm going to call this the adjacent. Over still r, the hypotenuse. Tangent, well, now we have it. Tangent is the y, which happens to be the opposite, over the adjacent. So we have now the ratios to sine, cosine, and tangent. Before I go to the next three, there's a little saying to help you remember this. I think I've mentioned this in a video before, called so, ka, toa. And where these are coming from, and let me do this in a different color, like maybe blue. The S stands for the so, right? There's the so. And then we have the ka right there. So ka stands the first letter for each thing. And toa. Tangent is opposite over adjacent. So ka toa. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. The reciprocal identities are in the second column, and we know that cosecant is just the flip of sine, so we know it's the hypotenuse over the opposite. Secant is the flip of cosine, so it's the hypotenuse over the adjacent. And finally, cotangent is the flip of tangent, adjacent over opposite. So you might be asking, what's the difference? Why are we even doing this? Well, now it doesn't matter what position our triangle is in. It does not need to be in standard position. So let me show you an example of that. Let's choose an upside down position where the right angle is right here. This is not in standard position. If I call this angle A, the initial side is not on the x-axis like it was above. But what I'm going to do is if I call this angle A, I'm going to call the side opposite of A, little a, and then I'm going to call this angle B. We always usually save C for the right angle. So I'm going to do the one across from B. We're going to call that little b. And at one across from the C, I'll call little c. And they'll usually do this. Now, if I'm going to look at the sine of A now, what is the sine of A? Well, let's go back to yellow. Because the side A was, if you remember, the opposite. And the opposite of A is going to be little a. Opposite of our hypotenuse. The hypotenuse is across from the right angle, so I won't highlight that. So that's going to be little a, and across from the right angle is going to be C. You can find the ratio no matter what position. It doesn't have to be x over r anymore. And then cosine. Cosine of A, again, let's do that in green. Cosine of A is going to be the adjacent, the one that's adjacent to the A, which is B, that's going to be B over the hypotenuse, which is C. And tangent of A. Tangent of A is going to be the opposite, which is the yellow, the A, over the adjacent, the one that's touching the A, that's not the C, which is B. And then you can find the reciprocal identities fairly easily by taking the flips. So cosecant of A is the flip of sine of A, and secant of A is the flip of cosine of A, and tangent of A is the flip of cotangent. What's so nice about this is you don't have to do A anymore. We could have done B. So let's try that. Let me erase the yellow and the green because the opposite and adjacent are going to be different for B. Sine of B. What is that? Sine of B. Sine of B is the opposite. It says up here it's the opposite over the hypotenuse. So let's go back to yellow for the opposite. There it is right there. Again, the opposite is the opposite of B, and it's the yellow. So it's going to be B over the opposite over the hypotenuse, which is B over C. B is the opposite. The hypotenuse is still C. What is cosine of B? That's the adjacent. So the adjacent of B, it cannot be C because that's the hypotenuse. The adjacent of B is going to be the one that's touching B. That is not the hypotenuse. So that is going to be A. Kind of weird, huh? Adjacent over the hypotenuse is the A over C. And then finally, tangent of B is the opposite, it says, which is the B, over the adjacent, which is the A. And again, you can find the flips. Cosecant of B is going to be the flip. Secant of B is going to be the flip of cosine, so it's C over A. And cotangent of B is A over B, the flip of tangent. So scrolling down, that leads us nicely to what we call cofunction identities. Because what I'm going to do is take any triangle where A is an acute angle. It doesn't have to be in standard position anymore. And we can say that here, the sine of A, I'm going to look at A here, and we know that the sine of that A is the opposite. The opposite is A over the hypotenuse, which is C. Again, here's the opposite, and C is across from 90 degrees to the hypotenuse. Now, if I did it in terms of B, the A in terms of B would be the adjacent, wouldn't it? With B, again with A, yes, it is the opposite. But with B, if you look in terms of B, A is the adjacent. So we know that adjacent over the hypotenuse is cosine. So we learned that the sine of A is the same as the cosine of B. And we know that A plus B is 90. They're complement angles because the whole thing is 180, A, B, and C, and C is 90 degrees. So that means A plus B is 90 degrees. And if we solve for B here, subtract A from both sides, you would get B is equal to 90 minus A. And I'm going to plug that into B here, and I'm going to get cosine of 90 minus A, which gives me the first identity. Now we could have done the same thing. We could have said the cosine of B is the sine of A. Similarly, if sine of A is the cosine of 90 minus A, then the cosine of A better be the sine of 90 minus A. So that is those two. So now let's look at secant. Let me erase all these little scratch marks of the colors. Secant. We know that secant, let's do tangent. Yeah, they're choosing A over B, so we're going to do tangent next. So let's say tangent. Tangent of A. Tangent of A is the opposite, again, the opposite of A over the adjacent of A. That would be that. So now, if I look at cotangent, it would be the flip of that. Look at terms of B, cotangent of B. So now we're going to erase this and do B. Cotangent of B. Cotangent is adjacent. So we have to do the adjacent first. Whoops, make that green. Adjacent first. Over, which is the A, over the opposite. The opposite is going to be in yellow here. Adjacent over opposite. So you can see that tangent of A is the same as cotangent of B, and we know that B is still 90 minus A. It gives us that one. And in a similar argument, you could do the same thing for cotangent. Now let's go ahead and do secant. Secant of A. What is secant of A? Well, secant we know is the flip of cosine. So it's the hypotenuse over the adjacent, right? Flip of cosine, and cosine, so katoa. Let's just write that again. So is the katoa. So secant is the opposite of the cosine, so it's hypotenuse over adjacent. So let's do adjacent. Adjacent we'll do in green. So I'm going to do A. The adjacent to A is the B. So that's why it is the opposite, which is the hypotenuse. Sorry, the hypotenuse over the adjacent. So it's C over B. That makes sense. Is that the same thing as cosecant? Let's try that out. They're claiming that this is the same thing as cosecant. Cosecant, that now we're looking at B, comparing it with B. Cosecant is the opposite of sine. Sine, or it's the flip of sine. Sine is opposite so, right? That's the so. So it's opposite over hypotenuse. So cosecant would be hypotenuse over opposite. And the opposite from the B is little b. So we know that that's going to be hypotenuse, which is C, over little b. Those are the same. So again, this is going to be B we know is 90 minus A. So this is cosecant of 90 minus A. We get the middle one. And then you can do the same argument, saying cosecant is secant of 90 minus A. Those are called cofunctions. You can see it in the name, sine, cosine. So finally, that's where the names are coming from. When you say cosine, we know that one of them is going to be 90 minus the other. Secant, cosecant. Secant of A is going to be cosecant of 90 minus A, and vice versa. And then tangent and cotangent. Tangent is 90 minus, tangent of A is cotangent of 90 minus A, and vice versa. Cotangent of A is 90 minus tangent. Sorry, cotangent of A is tangent of 90 minus A. So finally, let's do an example of solving equations using cofunction identities. So find one solution for each equation. Assume all angles are acute. So we know we have cosine of theta plus 4 degrees equals sine of 3 theta plus 2 degrees. And we know these are cofunctions of each other. So we know that they must add up to 90. So one way of doing it is you could say theta plus 4 degrees better plus 3 theta plus 2 degrees is the easiest way of doing it over here. That A plus B better add up to 90. We give it 4 theta plus 6 degrees is 90 degrees. So I'm going to subtract 6 from both sides. I would get 4 theta equals 84 degrees. Divide by 4. And you can see theta is 21 degrees. It says find one solution, and I did.